Hello everyone, welcome to the A plus generator. So we shall look at determining homogeneity of a function, and we say that a function is said to be homogeneous of degree r if by multiplying all the independent variables by a constant k, the dependent variable y changes by a multiple of k to power r. So I know that this explanation is a bit complicated, but we shall look at an example. So we have example 1. So if you have y is equal to 4x1 plus x2, so there are two independent variables in our equation, that is x1 and x2. So step 1, you have to multiply each independent variable by a constant k. That's why in our explanation we say you multiply all the independent variables by a constant k. So, and we've said that we have two independent variables in our equation, that is x1 and x2. So when you multiply by a constant k, you're going to have y is equal to 4kx1 plus kx2. So our next step is to allocate to the constant k the power allocated to the independent variable. And in our case, both the independent variables x1 and x2 are raised to power 1, as you can see. So we also allocate to the constant k the power that is allocated to the independent variable. So you have y is equal to 4k raised to power 1 and x1, which is also raised to power 1, plus k raised to power 1 and x2 raised to power 1. So the step number 3, you're supposed to factor out the like terms, that is the constant k, because we have two like terms. We have a like term, so we have a like term k, and this, so when you factor it out, you're going to have y is equal to k raised to power 1, then in brackets 4x1 plus x2. So in step number 4, you have to look at the power allocated to the constant k, and then you conclude that the function is homogeneous of degree 1 because you can see that k, the power allocated to k is 1. So the function is homogeneous of degree 1. So that is the reason why we're saying that when you multiply all the independent variables by a constant k, the dependent variable will change by a multiple of k to power r. So you have to look at the power allocated to the constant k, and that will give you the degree, the homogeneity of that function. So we shall look at example 2. So when you have q is equal to 80 m raised to power 0.2 and l raised to power 0.5. So step number 1, you have to multiply the independent variables by a constant k. So, and in our equation we have two independent variables, that is m and l. So you have to multiply the constant k by each independent variable. So that's why we have q is equal to 80k multiplied by m raised to power 0.2 and k times l, which is raised to power 0.5. So in step number 2, you have to allocate to the constant k the powers allocated to the independent variable. So you have to allocate to the constant k the power that is allocated to the independent variable. So in our case, we have q is equal to 80, k we are allocating 0.2 because the independent variable m is raised to power 0.2, and this other constant k, we are allocating it power, which is 0.5, because the independent variable L is also raised to power 0.5. So in step number 3, you have to factor out the like terms. And the like terms in our case is the constant k. And when you use the laws of indices, when you have two factors with the same basis, you have to add the powers. So in our case, we have the factor k, the constant k, and now you have to add the powers so as to factor out the like term. So that's why we have q is equal to k raised to power 0.7, because you have to add 0.2 plus 0.5 to get 0.7, and then you have the other factors, that is 80, m raised to power 0.2, and l raised to power 0.5. So in step number 4, you look at the power allocated to the constant k. So you can see that 0.7 is the power that is allocated to our constant k. So, and therefore, we make a conclusion that the function is homogeneous of degree 0.7. And then in our example number 3, you may pause this video and try to do this example. So you have y is equal to x to power 2 plus 5xw plus w to power 2. So remember that we've said you multiply a constant k to the independent variables, to each independent variable in the equation. So we have how many independent variables? We have 1 and 2, x and w. So you have to multiply the constant k to each independent variable in the equation. So that's why we have y is equal to k raised to power, you have y is equal to k x raised to power 2 plus 5. Remember, we have also independent variables here. So you have to multiply the constant k with each independent variable so that you can get 5k times x, k times w plus k w raised to power 2. So remember that in our next step, you have to allocate the constant k, the power that is allocated to the independent variable. So you can see in our next step, we have allocated k, the power 2, because the independent variable that the constant k is multiplying is raised to power 2. And then you add 5k times x. Remember that x is raised to power 1, so you give the k there. You allocate to k the power 1, and then also the w is allocated is raised to power 1, so you have to allocate to k the power 1, and in this case k you have to allocate power 2 because the independent variable w is allocated power 2. Then you can now use the laws of indices and add the powers allocated to k. So you can't add the powers in this case because you can't use the laws of indices in the whole equation, because remember that this is an addition sign, right? We have addition signs. So the only place that you can use the laws of indices is here, is in this case, where you have 5 k raised to power 1, x raised to power 1, k raised to power 1, and w raised to power 1. So because you can use the laws of indices in this case here, you can now rewrite the equation to be y is equal to k to power 2, x to power 2, plus, remember that 1 plus 1 is 2, so k raised to power 2, 5x raised to power 1, w raised to power 1, plus k raised to power 2 and w raised to power 2. So you factor out the like term, so you're going to get y is equal to k raised to power 2. Remember that you can't use the laws of indices in this case because we are not multiplying the constants. Remember, there is an addition sign in this case. So when you factor out, you're going to write the k raised to power 2, and then you open the bracket and write the other independent variables. So you look at the power allocated to k, to the constant k, in order to make a conclusion. So we therefore say the function is homogeneous of degree 2. Thank you for watching. Please comment if the video has been helpful, and let me know some of the topics that you'd like me to cover. Thank you.